Okay, students, we're going to go over practice problems in your first interim DCAS. They'll look something like this. Okay, find the volume of the rectangular prism. This is review from middle school, formulas from middle school geometry. You should know that the volume of a rectangular prism is length times width times height. So all we're doing is multiplying these two binomials together. Remember, you only can do two at a time. We did this at the beginning of the year here in your first test. Not the quiz from middle school, but the first test. All right, so we'll just go right in order. Now I'm going to show you another method. I've shown you the vertical method. Now I'm going to show you the box method. 2x and a plus 2. Okay, you can put the signs with there. X and a plus 3. Okay, now I go ahead and multiply x times 2x. You should know that's 2x squared. X times positive 2 is positive 2x. 3 times 2x is 6x, and 3 times 2 is 6. You've probably seen this method before. You can use the vertical method or this method. Now I combine like terms here, which are these two right here. So this answer is 2x squared plus 8x plus 6. Okay, now I need to multiply that by the 3x minus 3. So I'm going to do this one with the vertical method. So we've done, and you'll have seen both methods. You can choose which method you like to do. Okay, so let's change the colors here. Negative 3 times 6 is negative 18. Negative 3 times positive 8x is negative 24x. And negative 3 times 2x squared is negative 6x squared. You must remember to put your signs with each one. You should be saying it correctly as well. I don't just say 3 times 6. I say negative 3 times 6, negative 3 times 8x, negative 3 times 2x squared. Okay, now second row. 3x times 6 is 18x, and that's a positive, so put a plus with it. 3x times 8x is positive 24x squared. And the last one, 3x times 2x squared is 6x cubed. Okay, and now I just add straight down. I already have them lined up. So 6x cubed, 24 minus 6 is 18x squared. Negative 24 plus 18 is negative 6x and a negative 18. And there's my answer. Okay, so you're now seeing the vertical method again, as I taught you, but now you might be reminded of the box method, and you could do it that way both times if you wanted to. I just showed you both. All right, number 2 is similar. Two polynomials are described below. This is in function notation. Remember, when you see it like this, it's just function notation. This is basically like a y in a way. Just tells you a little bit more. But all you need to know here is it says to multiply. That's the multiplication symbol. Multiply those two functions together. So you're just multiplying those two polynomials together. Okay? So, I'll do the box method on this one. So I have a trinomial here, so x squared plus 2x minus 2, and I have a negative 4x and a positive 4. So again, you can go back and forth, whichever you choose. Vertical method, that's called the vertical method. And this is called the box method of multiplication. Okay, you can find these on YouTube as well. So negative 4x times x squared, let's change the color to negative 4x cubed. Negative 4x times 2x is negative 8x squared. And negative 4x times negative 2 is positive 8x. Put the signs with them. 4 times x squared is 4x squared. 4 times 2x is positive 8x. And 4 times negative 2 is negative 8. Okay, now I have to find the like terms. So if I look right here. These are both the x squareds right here. And then these are both the 8x's right there. So I have the negative 4x cubed, and I have negative 8x and a 4x squared. 4x squared minus 8x squared is negative 4x squared. 8x plus 8x is 16x, and negative 8 at the end. And there's my answer. Now, they might go ahead and have the x cubed, the x squared, the x there for your constant, and they just have boxes. And you're just be filling, and they might just have boxes like this that you're filling in the coefficient for, or the constant at the end. Okay? And you might be just filling in that right there. So again, there's the box method again. You could have done the vertical method like I just did on number 1. Okay? Notice we have another one. What's the product of, come on, there we go, of 2x squared and x squared. Product, again, there's testing vocabulary, multiplication. You should know that from elementary school onward. So I just did the box method. I'll go back and do the vertical method. Okay, so we have x squared minus x plus 1 and 2x squared minus 6. Notice these are both written in standard form. Remember, standard form means highest degree down. So I went degree 2, degree 1, and degree 0. And then here's degree 2, and then degree 0. There is no degree 1 on that one. You always write, and you write your answer in standard form. This is in standard form, highest degree down. Okay? So we're multiplying here. Negative 6 times 1, negative 6. Negative 6 times negative x is positive 6x. And negative 6x squared. Now I do 2x squared times 1 is 2x squared. I have to write that underneath the 2x squared. Combine like terms. I put it underneath like terms. 2x squared times negative 1 is negative 2x cubed. Okay. And 2x squared times x squared is positive 2x to the 4th. Okay. Notice I only line up the like terms underneath each other. And then I go ahead and write in the final answer. 2x to the 4th minus 2x cubed. Negative 6 plus 2 is negative 4x squared plus the 6x minus the 6. Okay, so vertical method. Again, your choice. All right, number 4, function notation again. And this is what's the final expression of g of x minus the f of x. So I have to first multiply this out, get that answer, and then subtract that from the g of x. Okay, so you have to pay attention to the order. They're doing g of x minus the f of x. Even though the f of x is on top, you're not just subtracting down. Pay attention to the order. All right, so we should know from the shortcut method, when I have x minus 1 squared, that is x squared, comes from multiplying the first term together. X times x is x squared. Multiply the two terms together inside parentheses. X times negative 1 is negative x, and then double it, negative 2x. That gives you my middle term. And the third term is taking the negative 1 times negative 1 to give me positive 1. Now don't forget to subtract that 1 off right there. Well, now those cancel out. Okay. And I'm doing g of x first. So it's 3x squared minus 3x plus 2. And then minus, what do I have right here? X squared. It has to be in parentheses minus 2x. Okay, so now when I go ahead and have a negative outside of parentheses, obviously I'm just distributing that through there. So all it does is switch the two signs. So now it becomes negative x squared. So I'm going to write that underneath the x squared, the like terms. And then I have negative times a negative is a positive 2x. I'm going to put that under the x term. I'm lining up like terms. And now I'm just going to add straight down because I've already distributed that negative through there. So 3x squared minus 1x squared is 2x squared. Negative 3x plus 2x is negative 1x, or is negative x. And lastly, plus 2. Okay, and there is your answer. So again, I'm working out all these. You're going to work out ones just like it with different numbers. I'm showing you all the steps, so there's no excuse for you not knowing how to do all these problems. You just follow the same steps I've shown you. Like I said, if you want to do vertical method versus box method, that's your choice. Okay. Number 5 now. The expression, this right here, can be written as k, some number k outside parentheses, times this whole thing. So that means this bottom piece is going to equal this top piece. Okay. So very simple on what to do. I just take any one of the terms. So let's say I want to do the 12x squared term. I compare that to the negative 48x squared term, the same term up there. I have negative 48x squared, and I just divide it by my same term right here, 12x squared. Well, the x squares cancel out, and negative 48 divided by 12 is negative 4. So that's what k has to be, negative 4. It doesn't matter which term I take this to, it's going to work. So let's say you want to do with the xy term. There's the negative 32xy. I divide it by its xy term right here, 8xy. Well, the xy's cancel out, and negative 32 divided by 8 is negative 4. Same answer. I could have done it by the y term. So I have 8y divided by the negative 2y. The y's cancel out, 8 divided by negative 2 is negative 4. Same answer. So k is negative 4. I don't have to do it for each one. I can just do it for one of those terms. What I'm doing here is I'm factoring out some GCF. It doesn't necessarily be the greatest common factor, but a common factor. Okay. And the way I do it, I just showed you. I just showed you 3 ways. You can pick any one of the 3 terms. You just divide the original by the new one, and that's going to give you where that constant k is that you factored out. Okay, factor completely. So let me erase this. Factor completely the following expression. Well, the first thing you do with factoring is take out the GCF, greatest common factor. So in numbers wise, between 3 and negative 48, what's the biggest number that goes into both 3 and negative 48? Well, 3 does. 3 goes into 3 and 3 goes into 48, 16 times. Now I look at the x's. Here I have 3 x's, x cubed. Here I only have 1. I can't take out more than 1 because this second term only has 1 x in it. The first term has 3 of them. So I can only take out 1 at most from each term. So I take out the 3x, that's the GCF. And now I write what I have left after taking out that 3x. Well, if you're not sure, you can just divide each term by 3x, and that's the answer that goes inside parentheses. So 3x cubed by 3x, you should know that is x squared, because you're subtracting your exponents. 3 minus, I got 3. I got more in the numerator than the denominator. How many more do I have? 2 of them. And the x's cancel here, and negative 48 divided by 3 is negative 16. Now, you're going to see that answer as a multiple choice to choose from. But that is, it says factor completely. This is factored so far, but it's not completely done. Okay? So to completely factor that, you'll see another answer that looks like this. Okay? Now, we didn't go from the factoring part to this, but in our worksheet earlier, we multiplied these 2 binomials together when the only difference was a positive and negative sign. And I told you, instead of it, normally when you multiply 2 binomials together, you get a trinomial. But there's a special case where you only end up with a binomial like this right here. And that's when one sign is positive and one sign is negative there. Okay, it wipes out the middle term. So if I multiply, so that means I just have to multiply the first 2 terms together. X times x is your x squared, and negative 4 times positive 4 is the negative 16. So this is a multiple choice question. You can always just take the answer and multiply it back together. okay, and see that that works. But this is called a difference of squares. When we get into factoring, we'll be going starting from here, and you'll have it memorized. But if you ever see a binomial, x squared and in a minus sign, so it's called difference of squares. And this is a perfect square because x squared is a perfect square. The square root of x squared is truly absolute value of x. Okay, but it is a perfect square, and the square root of 16 is a perfect square as well, 4. So both of them are perfect squares as they are here. All you do is take that square root, there's your x and your x, take the square root of 16, 4 and a 4, and one's a plus and one's a minus. That's called the difference of squares. Okay, that's A. B, what's the greatest monomial? Monomial means one that you can factor out of this expression when factored completely. Okay, so we're going to see, that's basically what it's asking is that what's the GCF? Okay, monomial, one term, you're taking out one piece, you're taking out a GCF here, is what you're looking at. Well, what I need to look at first here, if I just look at this, I might say, oh, the answer is 2 because I see a 2 in each one of those. Well, what you have to first do is combine like terms. Remember, we talked about this all the time, combine like terms and distributive property are our first steps. So the first thing I want to do is combine like terms. So I have 14x squared and a 44 minus 4 is 40. Okay. Now I'm going to factor out the GCF. Okay. That's what I'm looking to do now. So I could say 4 goes into 40, but 4 does not go into 14. Notice there's an x squared here, but there's no x's here, so I can't take any x's out. So the only thing I have is a 2 that I can take out. 7 goes into 14, but 7 does not go into 40. The only thing that goes into both of these is 2. So even though I could have got it from here, that doesn't mean that's going to always be the case. I need to combine like terms first, because then I might have a bigger one. Such as if this was a 14x squared, I would still be looking at that as thinking that's 2, but then I'd have a 16x squared here plus 40. Well, now the GCF between 16 and 40 is 4. No, sorry, it's not even 4, it's 8, right? 8 goes into 16 and 8 goes into 40. So that would be the GCF if that happened to be a 14x squared there. Okay, so always combine like terms first, then go ahead and factor out your GCF, which in this case was 2. Okay, number 7, solve for the equation. Okay, we just did this on this current test here, or this last test. Solving for x. Okay, so we need to get rid of everything else to the other side. Notice this is x squared right now. So we're going to have to also get rid of that little 2 and get down to 1x. So remember, we solve, there's no distributive property, no combining like terms. So we go right to solving all equations by reverse PEMDAS. Never changes. I'm going to add or subtract first. Remember, if I'm adding or subtracting, I'm always moving an entire term across. Well, here's my entire term over this plus 4. I mean plus r. So I'm going to, opposite of plus is minus r from both sides. Notice I don't line them up underneath the j because they're not like terms. So now I have 1/6 dx squared equals j minus r. Okay, remember this is all multiplied together. This on the left side because there's no sign in between. This is all multiplication. So I can get rid of these 2. Remember, I'm only getting rid of a part of a term here. I'm not getting rid of the full term. So when I'm getting rid of a part of a term, that's going to be multiply or divide. Okay, well, the reciprocal of 1/6 is 6. That gets rid of that. And division to get rid of the d. So I'm going to be multiplying by 6 over d on both sides. The 6 cancels there in the numerator, and then the d cancels there. So I have parentheses over here, multiplying by 6 over d. So now I have x squared equals 6 parentheses j minus r all over d. Okay, Now, they may or may not distribute that 6 through there. They may leave the 6 on the outside, or they may distribute it and have 6j minus 6r. Like this is going to be a multi-choice answer. Okay, so you're just looking at, I'd leave it like this to begin with and see if that's there. Now, remember, this is x squared. I want to solve for x to the first. So now I'm up to exponents. I have to get rid of that exponent down to 1. So I take the square root. Whatever I do to one side, I do the other side. So there's my final answer. X equals the square root. And technically it's plus or minus, but they probably don't have that on the test. They probably just have the plus, just without anything there. I mean, which means plus. Okay. That's a D in the denominator, just like it is up here. Okay. And there would be your answer. So I'm doing reverse PEMDAS. Add or subtract the term across, then multiply or divide a part of a term, and then get rid of my exponent last there. Okay, reverse PEMDAS. Okay. Number 8. We're now solving again for terms here. So to find V in terms of A and M. So it really just says find V, what it means. When it says in terms of A and M, that means A and M are going to be your answer. You better not be thinking of getting rid of A and M, but you're solving for V. When it says find V, that just means solve for V. So again, we have reverse PEMDAS. Okay, just like the last one. So that means it's showing you're going to have multiple problems of this. Remember, this is called a literal equation, solving a literal equation. So we got to get V by itself. I got to get rid of that and this. Well, this negative M is an entire term. So I'm moving that across first, plus or minus for the entire terms, add or subtract. So the opposite of minus M is plus M. So now I have A plus capital M equals 0.6 V. Okay, and that means 0.6 times V, so the opposite is division. 0.6 V. That cancels out V equals A plus M over 0.6. Now, they may not have it like this. They might change it, because oftentimes they don't like decimals and fractions. So what you could have done, because this is more likely to be the answer, at 0.6 V, I'm going to change that 0.6, and that means 6/10, which then simplifies to 3/5, because we always reduce fractions. So this 0.6 is the same thing as 3/5 V. So now I just go ahead and multiply by the reciprocal, 5/3, and that equals 1. Those cancel out. So on this side, I'm multiplying by 5/3. So that would be my answer. V equals 5 times the quantity, A plus M all over 3. Okay, that's more than likely how they're going to have it. They don't usually leave decimals in a fraction. All right, find X in terms of B. Again, that just means B, capital B is going to be your answer. You're solving for X. Reverse PEMDAS. Add or subtract first, so add that 15 across. BX equals 15 minus 4 is 11. Remember, I'm solving for X, so the last step is to divide by B. And I'm done. X equals 11 over B. Very simple. All right, number 10. Okay, 4 tests and the final exam make up a student's grade. He needs 89.5 or higher, because that'll round to a 90 to earn an A. His 4 test grades are these. Final exam counts 2 test grades. So you have these 4 plus an X plus another X counts 2 test grades. Whatever they are, they count twice. What does he need on the final exam to earn an A in the class? His final exam cannot exceed 100%. You can't get higher than a grade than 100%. So remember, to find the average, we add up all the numbers, and in this case also variables as well. Divide by the total number there are, which is 6. 1, 2, 3, 4. The numbers in 5, 6, because the final exam counts 2 test grades. And then set that equal to 89.5. Okay, so we have to score at least 89, which means greater than or equal to 89.5. So I add these up. 172, 178, 268, 293, 363. 363 plus 2x divided by 6 tests equals, and really I'm putting an inequality sign, greater than or equal to 89.5. Okay, so the opposite, remember this entire thing is like a parentheses there, remember, because there's more than one term. Remember when there's more than one term in the numerator denominator, you put parentheses around it. So again, we're doing reverse PEMDAS. And now those, you see that parentheses is up top, so I can't do that first. I have to do add or subtract, which there is none because I'm not moving an entire term. This only is one term here. So I'm getting rid of parts of that term. So the first thing I'm getting rid of is that 6. So the opposite of divide by 6 is multiply by 6. So multiply both sides by 6. That cancels that out. Okay, now I have 363 plus 2x equals. Okay, so if I go ahead and do that, that's 6 times 90 is 540 minus 3 is 537. That should be what you get there. Okay, you can put it in a calculator. This will be on the calculator part of the interim. Subtract the 363 across now. 2x equals, that's a 4, borrow, 13 minus 6 is 7, and 4 minus 3 is 1. And last step, divide by 2, and I get 87. Okay, 87 times 2 is 174. So, remember it's a greater than or equal to sign. So, x has to be greater than or equal to 87. He has to score at least an 87 on his final exam to end up with an A average. Okay, number 11. You can do this one as 11 and this one is 12. Okay, we graphed these earlier in the year. Remember, this is called standard form. AX plus BY equals C is standard form. A, B, and C are all integers, and A has to be greater than 0. Standard form, remember, the two easiest points to plot are the X and Y intercepts. So if I make X equal to 0, Y equals -9. Okay, that's going to take me a little bit off. If I make Y equals 0, X equals 3. Okay, so 0, -9, 7, 8, 9, and 3, 0. Oops. 3, 0. Now, if you're doing it on a computer, on a DCAS, okay, and they make you plot the 2 points, this is not it's not a multiple choice, they make you plot the 2 points, you can't go beyond down there. They probably already have enough on there for you. They're not going to make it go off the grid. Usually at all, but if it were so, I could change it and make like instead of 0. Well, so first off, this is using standard form of doing the two easiest points, X and Y intercepts. I could also just solve for Y, which just means add the Y across to get a positive Y, subtract the 9 across, and I have that equation, Y equals 3x minus 9. There's the minus 9 down here, up 3, 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, right 1. And I'd have my line right like that. So you can also solve for Y, put it in slope-intercept form, and graph it that way. Okay, and not nicely drawn, but that would be my answer. Okay, next one, I have another standard form one. Okay, a little harder, put it into slope-intercept form. So again, the easiest points to plot are the X and Y intercepts. If X is 0, crosses it out. Y is -3. If Y is 0, crosses this out, and 3x equals 12, x equals 4. So there's my 2 points I plot. 4, 0 right there, and 0, -3 right there. And then go ahead and draw your segment through there. Okay. Sometimes what they'll do is they'll make you pick 2 points on the line. So I just pick those 2 points, and then it would connect it for you. Okay, and then hopefully draw your arrows at the end as well. It should do that. Okay, so you'll either plot 2 points and it'll connect them for you, or it's a multiple choice with graphs there and you choose it. Okay, number 13. we have to graph these two. Notice it says in quadrant 1. They're not going to tell you that, but that's real life problems are in quadrant 1. So I'm making this the y-axis, this the x-axis. Okay, you're going to have to fill in your own. Oops. Y, x. You have to fill in your own. So notice I'm a plus 45 for the y-intercept. So I'm going to go by tens here. 10, 20, 30, 40, 50. So 45 is, that's 40. So 45 is right there, halfway in between. And then my slope is 20/3. That says go up 20 and then right 3. Okay, now I'm going to go ahead and go by ones down here. Okay, like this. So I'm going to go up 20. It's going to put it 20, remember, because slope is change in y over change in x. So y is either up or down. So I'm going up 20 plus 20 and then right 3. Okay, x is left or right. So from 45, I'm going to 65. Well, there's 60, there's 65. I'm going right 3. 1, 2, 3. Okay. And there would be my right like this. Okay. And then the second one is 10x. Remember, that means 10x plus 0. So that means it's starting at 0 right here. We're going up 10, right 1. Up 10, right 1. Up 10, right 1. Up 10, right 1. Okay. So there's that one. And this is going to be multiple choice, and it'll have the graphs on there for you. Okay. I need to move that slightly over to get it more accurate. Okay, and then keep going. So mine didn't quite intersect on how I did the graph going by ones down here, but this is multiple choice, and it will intersect on your DCAS. Okay, they'll actually have the graphs there for you. It's multiple choice, so you're just picking these ones that have the y-intercept of 0, as it shows there, and y-intercept of 45, and these slopes. And they'll cross, they'll intersect, okay, and you're going to pick that point. Okay, so that's how that goes right there. Okay, graph the following system of inequalities. Okay, again, we have them in standard form. Easiest points to plot, x and y intercepts. So if x is 0, y is -2. If y is 0, x is 3. So 0, -2, right there, and 3, 0, right there. Okay, and it's not underlined, so it's a dashed line. I'm just going to quickly, this is running out of time here for class. And then down here, if x is 0, y is 1. If y is 0, x is 2. So plot 0, 1 right there and 2, 0 right there. Again, it's not underlined, so that's going to be dashed like that as well. And then shading, okay? Now, if the coefficient on the y is positive, as it is there, then we keep that same sign, greater than. So the second one is greater than. So it's now going to be either in this quadrant, in this area, or in this area, because it's greater than that line. Okay. Now in the top one, since the coefficient is negative, we need to switch that inequality sign. So we're going to also shade above that, which then means it's going to be either in that one and that one. One of those two. So which one do we see the dot in both of them? This area right here has a dot in both. So that would be my answer. You could also pick a point in each of these regions and find out which one is true. It satisfies both inequalities. If I pick anything up here in this purple region, it will satisfy both of those original inequalities. Okay. This one right here, y equals ax plus b, where a and b are positive. So I can just make up an example, such as y equals 3x plus 4. So there's plus 4, 3x up 3, right 1. Okay, and there to be that line, for example, right there. And then here it says C and D are both negative. Make one up like that. Negative 2x minus 1. So plot negative 1, go down to right 1. Okay, graph that line. So it says which quadrants must contain the solution and justify your answer. So it's going to be either in quadrant 2. Remember, this is quadrant 1. This is quadrant 2, quadrant 3. Remember, you use Roman numerals. Quadrant 4. So the solution right now for that one is in quadrant 2. So it could be in quadrant 2, or if this was flatter, okay, I could have had another one where the line might have come like this, and this came down here, and then intersected in quadrant 3. So quadrant 2 or quadrant 3 are my two possible quadrants. Do the two lines intersect? Yes, they do, because one's a positive slope and one's a negative slope. The only time, and you could just say that, okay? If so, describe their location, justify your answer, justify your answer that they intersect because these slopes are not the same. Okay, so they therefore intersect. Again, it'd be quadrants 2 or 3 for that. All right, I think that was it. Yes.